supposed to consider a right triangle. So here is, there's a right triangle with side A, opposite angle A, side B. So that's pretty conventional. Capital A is an angle, and then lowercase a is opposite of it. So we can call this one capital B, and this lowercase b. And then side C is the hypotenuse. So we got to make, since it's a right triangle, we got to be clear on what the hypotenuse is. Find the lengths of the missing sides. We're told that sine of B equals 1/2. Okay, so in order to get B by itself in this equation, it's the sine function of B. So you can use the inverse sine function, but you have to keep the equation balanced by doing that to both sides. And so the way I'm going to do that with my calculator is if you type in 1/2, so 0.5, then I'm going to hit trigonometry, second, and there's my inverse sine. So this right side in degrees, it's 30 degrees. And so sine, the inverse sine of sine, those are inverses, so they cancel each other out. So we just found out that angle B is 30 degrees. They told us lowercase a is 16 degrees, so instead of writing a here, I'm going to write 16 in its place. And we're supposed to solve for B and for C. So when you have a right triangle, you can use the right angle trig function, sine, cosine, tangent, cosecant, secant, cotangent. The way they work is that sine of some angle is equal to the opposite side divided by the hypotenuse of the triangle. And the opposite refers to angle theta. So like if we try to use sine on this angle right here, then sine of 30 equals the opposite of 30, which is the letter B there, divided by the hypotenuse of the triangle, which is the letter C. So we're stuck, right? We actually can't use sine of 30 because then we have two unknowns. So let's try something else. If we use sine of, sorry, I just did sine. Let's try cosine. Cosine of an angle is the adjacent over the hypotenuse. So if we try to take cosine of angle 30, of the 30 degree angle, then the adjacent is whatever is not the hypotenuse, whatever is not the opposite. So this is the opposite. This is the hypotenuse of the triangle, right, because it's across from the right angle. So that means this is our adjacent side. The adjacent side is the number 16. And the hypotenuse, something we don't know, letter C. But now you got an equation you can solve, right? We can get C by itself. We just got to do a little bit of algebra. So let's plug cosine 30 in our calculator. And you can use the decimal approach since, oh, they are asking for exact answers. Yeah, because if you use cosine of 30, you get this yucky decimal. The other way of knowing this is there's just a couple of trig triangles you can memorize. And so what's opposite of 30 degrees? And if the hypotenuse is considered 1, it's opposite's always going to be 1/2. This is square root of 3 over 2. So cosine of 30 is the adjacent, which this is one of those triangles I can always send to you if you'd like. We'll finish. Oh, I said square root of 3 over 1/2. Man, that's confusing. Let me back this triangle up. Sorry, so this is the triangle I usually have students memorize. There's a second triangle for 45 degree angle, right angle triangles, but so with any triangle, when you're using trig, if one of the angles is 30 or one of them 60, then what's opposite of 30 is 1/2, and what's opposite of 60 is square root of 3 over 2. So when you're trying to analyze cosine of 30, you can think of this triangle that I've drawn in the unit circle because the radius would be 1. Right? So think about that angle 30. What's the cosine ratio? Cosine is the adjacent divided by the hypotenuse. So square root of 3 over 2 divided by 1. So cosine of 30 is the square root of 3 over 2. And we got to use those fractions, I think, because they're looking for exact answers. Okay, so again, cosine 30, that's something you could memorize too. That cosine of 30 is always going to be square root of 3 over 2. Sine of 30, it's always going to be 1/2. Cosine of 60 is 1/2. Sine of 60 is square root of 3 over 2. Those are just some like trig values you could memorize. But that's what they mean when they say the exact values. Okay, it's got to be this. Because look, we got a decimal value when we plugged in 30 degrees. If you do the square root of 3, the square root of 3 divided by 2, that makes the same decimal value we got. And so now you've got just a ratio to solve, a ratio equation. You can multiply across the diagonal, so square root of 3 times c equals square root of 3c, and then multiply across these diagonals. 2 times 16 makes 32, and then you got to divide square root of 3 from both sides. So this is the exact answer. I don't know if sometimes they want you to rationalize the denominator and sometimes they don't. But the way I type this in is I type 32, and even to be extra safe, put parentheses, and then divide by parentheses sqrt, I think is the key word for square root in Mobius, right? So 32 divided by the square root of 3. We'll see if it likes that. If not, we can because the other way of doing this is multiply the top and the bottom by the square root of 3. This is equivalent and actually what you usually see. We found out what C was. C, the exact answer, is 32 over the square root of 3. Now to find out what B is, we actually don't have to go back to right angle trig. What you can do is you can use the fact that A squared plus B squared equals C squared. Right, so our A was 16, our B is something we don't know, and our C is 32 over the square root of 3 squared. And now if you solve using the Pythagorean theorem, you can find out what B is, and you don't have to use sine, cosine, tangent. You could use sine, cosine, tangent. It'll get you the same answer. But so 16 squared is 256. And then look, when you square this one, 32 squared makes 1024. The square root of 3 squared gives you just 3. And I don't think that's divisible by 3. No. So we've got to leave it like that. So still trying to get B by itself, not relying on decimals because I said exact answers. So let's subtract 256 from both sides. So get B squared equals 1024 over 3 subtracted by 256. We need common denominators. So let's put this over 1. And that means with that second fraction we got to multiply the top and the bottom by 3. So 256 times 3 gives us 768. Now we can combine them now that they have the top and the bottom are the same. 1024 subtracted by 768. Still not divisible by 3. Shoot. We get 256 over 3. And now to finish this out, you got to take the square root of both sides, right, to get B by itself. So B is the square root of 256 over 3. And I hope it likes that answer. We can try typing that in. If not, there's equivalent. Oh, actually, we can simplify that a little bit. B is the square root of 256 over 3. But that's the same thing as the square root of 256 over the square root of 3. And the square root of 256 is just 16. So this is our answer for B. And to type that in, we're going to type 16, divide by, parentheses, square root of 3. And then just watch, make sure to count up your parentheses. Let's submit that. If it doesn't like that answer, we can rationalize the denominator like we talked about. What question was that? I forgot. Oh, that's what I did before. It liked that answer. So the way I was typing it works, but they also accept the rationalized answer too. So if you multiply the top and the bottom by 1 in the form of square root of 3 over 3, you get 16 square root of 3 over 3. Okay, but what we just typed in, what we did here, is also accepted in Mobius. Okay, kind of a big problem. Hope that one worked out okay, but message me if you need some help.